It might be recorded. So, the basis of computer science is math. So first of all, we have to know how to do the Fibonacci sequence ourselves, and then we can make a computer do it. So I'm just going to write out this Fibonacci sequence. 5, 8, 13, 21. So the premise of the Fibonacci sequence is that you add one number. This is sequence of 0. And then this is the sequence of another number. So if you add these numbers together, you get this. You add these two numbers together, you get this. And so on and so forth. So we want to make an algorithm that remembers what it adds before, and it kind of just keeps going, right? So he gave us a hint that we should start off by defining an array with the first two, because let's just assume that we know 1 and 1 is the start of the Fibonacci sequence. Then what I did was I made two variables, sum 1 equals 0 and sum 2 equals 0. And my idea was that we would change sum 1 and sum 2 based on the current members of sequence so that we can add them together and we would get current, which would just be 2 in this case. So of course we're going to run it through a for loop. Because this time we don't have a certain length for sequence, so we can't use length of car or whatever we did there. So I'm just going to use, let's just say 1 to 10. This is special notation because 1 means that I, or whatever variable you can put count or whatever, it starts off at 1, then it keeps going to 2, 3, and 4. We did this because we want, okay, well, let me just write my algorithm first. And the first step is that sum 1 equals to, well, s sequence of I minus 1. So if this is 0, 1, 2, then we want to get whatever I is, we want to make sum 1 this one, and we want to make sum 2 this one. So if I is 1, then that means sum 2 is s of I, that's 1, and this one would be this one because we minus 1 from it, so this would be 0. So it would be sequence of 0 when I equals to 1, and it will. So next we just add the second number, and since this one is sequence of 1, we'll just do sequence of I. I'm such a bad teacher. Okay. So this basically gets from the value I the two letters that we're going to add together for our current 1. So now that we've got these letters, we have to add them together. Current equals to sum 1 plus sum 2. And here, what I like to do is I try to run through this like I'm a computer. So if we're going to read this line, well, I can see that I starts from 1 and it goes up to 10. So that means I is going to go, I equals to 1, 2, 3, 4, 5, 6, etc. So now let's just assume that I equals to 1, which is the starting point for I, as I said. So sum 1 equals to sequence of I minus 1. So I is 1, so that means that sum 1 equals the sequence of 0. Sequence of 0 is its first term, which is 1. So right here we know sum 1 equals to 1. And sum 2 is sequence of I. Since I is 1, that means sum 2 equals sequence of 1. That means sum 2 is also 1. Now we see current equals sum 1 plus sum 2. Sum 1 is 1, sum 2 is 1, so current is going to be 2. And of course we want to keep the array going because it has to make the array bigger as you add all the numbers. So I don't think we've learned this yet, but it's a strategy called append. Basically, it's a function that allows you to append or add another entry to a certain array. So right here, we're just going to write sequence dot append parentheses, and we're going to write current because that's a new number that we formed by adding them. In this way, when the sequence has appended current, it will now become 1, 1, 2, because as we calculated, current is 2 when I is 1. So now that this cycled once for I equals 1, now we're going to write this loop for I equals 2. And let's just do this one more time just so that you guys can see how it works. So when I equals to 2, sum 1 equals the sequence of I minus 1. That means sum 1 equals sequence of 1. Sequence of 1 is 1. So sum 1 equals to 1. And sum 2 equals sequence of I, but what's different is that I is 1 bigger. And that means sum 2 is sequence of 2. Sequence of 2 is 2. So sum 2 equals to 2. And of course, current equals to sum 1 plus sum 2. So current equals to 3. And then you append 3 to the array. You would add 3 more. And then this would repeat. But next time, sum 1 would be 2. Sum 2 would be 3. Current will be 5. And so on. And this continues until I equals 10. So that means, well, sum 1 would equals to sequence of 9 and such. So you can make this number as big as you want, but you're just going to print extraordinarily big numbers if you make it too big. So that's how you print a Fibonacci sequence. Yeah.
That's good. Good job. Good job. All right, there we go.